Hi scholars, today we're going to continue to talk about different ways that linear equations or ideas about linear functions show up on the SAT. Just a quick review, right? One way that we can approach any problem is sort of going through these 5 steps. First is to annotate the problem, so what information matters. Just note it, put a box around what you're being asked for. That's a very important piece. Second step is you want to summarize. What is this question really asking, right? See if you can put it in your own words. Often that simplifies the problem, sort of pulls out what is essential about the problem. You want to create a plan, solve it, and check your work. Now, keep in mind for some of these problems, if you immediately see what the pathway is, solution pathway is, right? So that's fine. You don't got to annotate. You don't have to summarize, right? You can just start right here with planning. It saves yourself a little time, right, if you know sort of the direction you're going in. And oftentimes, you're able to identify that direction, right, by seeing, being able to answer the question, does this problem look familiar, right? Are there keywords? And if you say, yes, oh, there are, oh, it is familiar, oh, right, it's a system of equations, then you just go directly into solving that system of equations. All right, so let's take a look at a couple of examples. They're sort of varied, and we'll go through them fairly quickly. So again, when you're doing these problems, I encourage you to pause the video, try to do it yourself, and then if you are stumped or need a little additional help, you can unpause the video. Okay, so here we have a graph. Before I even read the question, looks like I have years on the x-axis, so years are increasing from 1960 to 2010, and we're counting the number of miles traveled in billions, right, by air passengers. So in other words, more and more people are going on airplanes. Okay. According to the line of best fit in the scatter plot above, so this right here is a line of best fit. It's a line that's drawn to minimize the distances between that line and all of the actual data points. And here it does it pretty well. You can see the data points are fairly linear. Okay, according to the line of best fit for the scatter plot, which of the following best approximates the year in which the number of miles traveled by air passengers in country X, okay, was estimated to be 550 billion. So again, these numbers are in billions, so this is actually probably a fairly straightforward problem, which is nice. There are some on the SAT, of course, right? So I can go right up and I can say where was 550 billion? It looks like it's right here. And then I'm just going to go across, get to my line, and find out at what year was that. And so I'm going to go down, right? See what's happening. And without even looking at the answer choices, I'm saying 2004 looks right to me, right? Because you see, if that's 2000, that's 2010. This must be 2005. It's a little before. And I don't see 2004, but I see 2003, and that's probably the closest answer, right? And that's a pretty good estimate. It's got to be somewhere between 2000 and 2005. And we're done. All right, let's take a look at a couple that have a little more of an algebraic flavor to them. In the system of equations above, and here they are, k is a constant. So that just means k is a number, some number, okay? And x and y are variables, okay, fine. For what value of k will the system of equations have no solution? Okay, so first off, just a quick review about systems of equations, right? Here's a quick x-axis. I think it's easier to sort of see it graphically. A system of equations, linear equations, which both of these are, is basically saying if you draw 2 lines, what happens, right? And there are 3 possibilities. One possibility is the lines intersect at a point, and in this case you have one solution, right? So we can say that's a case where we have one solution. Another possibility is the lines are parallel. If they're parallel lines go on forever, they never meet. That's the joke, right? 2 parallel lines, they have so much in common, it's a shame they never meet. It's a pretty good joke. And these, if we asked where is a solution, meaning where do these 2 lines intersect, the answer is they do not intersect. In fact, that's what this question is asking. No solution is another way of saying when are these 2 lines parallel? And just to sort of finish things up, another option for 2 lines is they could be the exact same line, right? In which case, the question of where do they intersect is everywhere, right? In which case, they would have infinite number of solutions. Okay, so these are our three possibilities. So we know that right now we're looking for when these two lines are parallel, in which case they would have no solution. And what do we know about parallel lines? Well, we know that parallel lines have the same slope. So one way of approaching this problem could be to change both of these equations into y equals mx plus b form, right? You could do that, right? Subtract 4x, divide by -5, and then compare the slopes, and then make sure that the two slopes are equal, right? Because basically we want to solve for k, this value here. That's a possibility. I want to actually show this problem to you using a shortcut. And the shortcut is that if two equations written in, this is called standard form, when it's like, standard form is like ax plus by equals to c, right? Okay, so the shortcut is, if two equations, if they're written in standard form, you don't really need to actually calculate the slopes. You can just compare the coefficients a and b, right? So in this case, so I'm just saying, let's compare the coefficients a and b, and the coefficients must be proportional, right? In one equation must be proportional to the other. So what does that mean? That means I can look at k and -3, and I can write down the ratio k over -3, okay? And I can look at 4 and -5, right? And I can again write down the ratio 4 and -5. And if these two lines have the same slope, these two ratios must be equivalent. In other words, this is a proportion here. And when you got a proportion, hallelujah, right? Let's just cross multiply. So we get our -5k. Well, it doesn't matter. I'll do our -5k equals to -12. Divide by -5, you get that k equals 12 over 5. And there you go. There's our answer, okay? So one question, I mean, before, not for this particular question, but one question you might want to ask yourself is, how come that's true? How come that trick of just comparing the coefficients in standard form, how come that works? How come you don't have to go through the tedious process of solving in a y equals mx plus b form in order to compare the slopes, right? This is a shortcut, but with any shortcut you want to think and say, why does that shortcut really make sense? Okay, let's do one more problem. The graph of a line in the xy plane has a slope of 2 and contains the point 1, 8. The graph of a second line passes through the points 1, 2 and 2, 1. If the two lines intersect at the point AB, what is the value of a plus b? This right here is a problem that is screaming questions to ask yourself. Does it look familiar? Keywords. Does it make sense to draw a picture or a graph? Can I map the question out in another way? Yes, let us try to use this strategy. And I'll tell you why. Because they're talking about points, slopes, other points, and I need to have a picture of what's going on here if I have any chance of answering this question. So here we go. Let's do a nice quick sketch. We have our x, we have our y, and let's look at the first line. It has a slope of 2 and it contains the point 1, 8. So if I go over 1, right, I go up 8. Let's say here's our point right here. Let's say that's 8, right? And let's say this right here is 1. And it has a slope of 2. Okay, so if it has a slope of 2, it means if I go over 1, I go up 2, right? That's what it means. And I could also go use that slope to sort of go backwards to find out what the y-intercept is. If I know what the slope is and I know what the y-intercept is, I can write it in the form y equals mx plus b. And that seems like it could be sort of useful here, okay? So I can actually say if the slope, right, the slope is 2, I can sort of sketch it. And I can see that means if the point 1, 8 is on the graph, it means that go down 2, go over 1. This looks like it'll be the point 0, 6. And so this first line that we did just from sketching it and sort of reasoning about what slope means, I can rewrite this line as y equals 2x plus 6. That's great. If I got one line, all I really needed is the equation of the other line, and now I can sort of be in business in terms of finding where they intersect. Okay. The graph of the second line, let's do it in a different color. We'll do it in blue. So the graph of the second line passes through the points 1, 2. So here's 1 and there's 2. There's a rough sketch of it. And 2, 1. So 2, 1 means I go over to 2, okay, and I go up 1. And so let's say it looks something like that. Now, right here, if it's 1, 2, and 2, 1, I can see immediately the slope here is -1, right? Because when I go over 1, I go down 1, okay? So if I wanted to try to sketch that graph right here, I can see this right already. I know that this line looks like y equals negative x, -1x. Here, I'll just write it explicitly, right? The slope is -1x. And then the question is, where's the y-intercept? Well, if this right here is the point 1, 2, right, which was given to us right up here, then I know that I can just go over 1 and up 1. That's going to be the point 0, 3, okay? Here, I'll just draw an arrow here so we can, it's a little difficult to see. That's going to be the point 0, 3, means our y-intercept is 3, and I have -x plus 3. Now at this point, I got a system of equations. I can easily solve it algebraically, right? If I wanted to. I could also reason, just trying to reason through the graph. Let's just solve it algebraically because we did a lot of graphical reasoning already. So let's set the y's equal to each other. It's probably the easiest way to deal with this problem. So I have this, actually let's just clear a little space over here so we can actually get to writing. So I have that 2x plus 6 equals to -x plus 3. I can add x, I can subtract 6, I end up getting that 3x equals -3, x equals -1. Okay, if x equals to -1, I can plug that value in here or in this equation. In either case, I find out that y equals 4. And this xy pair, so this pair which is -1, 4, that's the spot where they intersect, right? So here we'll just give it a different color. There we go. That's the spot where they actually intersect. And so we're done. Well, no, we're almost done, right? If they intersect at the point A, B, they want to know what's the value of A plus B. So you do all that work to get these two numbers, and then they say, could you please add them? Okay, fine. I can add -1 and 4. You get 3. And that's all there is to it. Have a great week.